Hello all. Today's video is with respect to Nvidia Jetson Orin. The reason why we are speaking about Nvidia Jetson Orin and this Nvidia boards is because Nvidia is going to be one of the pivotal building block for the SDV vehicle because most of the OEMs are considering Nvidia as their hardware for running their AI applications and the compute intensive applications. So this particular video is split into five parts. We'll be speaking with respect to the GPU architecture, what is the SOC system on chip, with respect to NVIDIA Jetson, what is NVIDIA Drive, and the SDK manager or the ecosystem, what NVIDIA speaks about. So these are some of the NVIDIA architectures which are evolved from 2011 to 2023. So you can see that the latest race for the NVIDIA hardwares by Meta, or by Microsoft are basically the H200 chips, which are the Hopper 200 chips, and Ampere is the previous version of that particular chips. So these chips basically are very similar to the CPU architecture, which has grown over a period of time, where the efficiency doubles and the size of the chip and the power consumption reduces by half. So, anyways, you can follow this link to briefly understand with respect to the GPU architectures, because as the architectures evolve, the number of TOPS, which enters trillion operations per second, increases. The number of cores in the particular architecture increases, and the number of tensor cores also increases. So this is all with respect to the GPU architecture. Please to have a look at this link. Now the SOC. So this particular image is basically the SOC of Tegra X1. So SOC is system on chip. So in an SOC, basically we have the GPU, we have the CPUs, and we have all the other functionalities which basically are needed for driving a particular board. So in the Tegra SOC, here we are speaking about the Maxwell architecture GPU, which we can see over here with respect to the GPU, and here it speaks with respect to the flops which are available over here. And here the A57 and A53 are the CPU processors which are used by this particular uh, uh, Tegra X1 chip. So the information can be seen in both of these links. So a reason why why I'm speaking about this particular SOCs is because the NVIDIA's naming convention is something like this. So the latest chips, which are NVIDIA Orin, are nothing but the latest version of their SOCs, system on chips. The previous version of them are the Xavier chips, and the next version, which will be coming after Orin, are the Thor chips. So these are the SOCs which basically use the latest hardware which has been released of the GPU hardware, which basically differentiates the SOCs. Now, if at all you speak about the Orin SOC, the Orin system of chip or the Orin family of it, all of them basically use the Ampere architecture, Ampere GPU architecture, where they vary with respect to the number of flops they have, where they have the number of tops they have. And as you can see, these are the CPU processors which are available. So here you can see that there are 12 cores of A78, which is the topmost model of AGX Orin 64, and the Orin Nano basically has 6 cores of the same A78 chip. So the details with respect to these chips are available in these links, and you can even have a look at the Xavier and Orin. So Xavier uses the previous version of the GPU architecture. I think the previous version of GPU architecture which Xavier was using was Volta. So it was using Volta GPU architecture, and Orin uses Ampere architecture. Now now taking these chips and creating an embedded board of it. So Jetson board is basically one version of the embedded board which are available. for the industrial and robotics use cases by Nvidia. So they are now it is called as Jetson boards. Now, if at all you want to, so there are other set of boards also, which are basically for autonomous driving. So those boards are called as drive boards. So if we come to the Jetson boards, so these are the various Jetson boards which have been released by NVIDIA over a period of time. As I was saying, the Volta or the Jetson Xavier was the previous version of the Jetson boards, which were using the Volta architecture, Volta GPU architecture, and it was having a previous version, and it was having an inferior version of the ARM processors. Now, as I have discussed, the Orin basically this Orin HX is built on the Orin SoC, similar to this one Orin Nano, but the variations of these SoCs are with respect to the uh, number of cores the GPU has, and the number of CPU processors and other. These are the primary specs which can be clearly seen over here. So you can see with respect to the number of cores which are available in the GPU on an NVIDIA Orin compared to an Orin Nano, which has 1024, and it has 6 cores of CPU and it has 12 cores of CPU. Okay. So this is the variants which are available by which are made available by NVIDIA. So it is the Jetson AGX version, Jetson Orin NX, and the Jetson Nano. We can see the differences of over here. You can see you can basically choose what board you want based on your own performance requirements and based on your computational requirements. All the details can be found in this link. I will anyway share this PPT also. Now, NVIDIA Drive is another version of, or maybe the another hardware which has been built using the same SoC. The image which I'm showing over here is built on Xavier SoC. So the primary difference between NVIDIA Drive and NVIDIA Jetson is with respect to the stringent requirements which are needed for each of the use cases. So NVIDIA Jetson is basically built for use cases which are like industrial use cases or robotics use cases where the where the hardware requirements are not so stringent. But with respect to NVIDIA Drive, the hardware requirements are quite stringent because you are trying to because there is an SL constraint, automotive safety integrity level constraint, which basically has to be met to keep it as part of the car. So the hardware architecture, I mean the hardware requirements are quite stringent compared to NVIDIA Jetson, and this basically boils down even to the operating system also, which will be flashed in both of these OSs or both of these hardwares, because Jetson boards will have a Jetson OS, whereas NVIDIA Drive hardware will have a NVIDIA Drive OS. Now, with this, if at all we have to flash any of the uh, NVIDIA boards, basically NVIDIA provides something called as an SDK manager. The SDK manager basically makes when is installed in a host of an x86 hardware, and the board, whatever it is, it could be the drive hardware or could be Jetson hardware or whatever version of the Jetson hardware can be directly plugged in to this particular host, which is x86 machine via USB. Once that is done, the necessary packages for the particular board will be can be flashed via this SDK manager. So that particular flashing is done in a form of a Jetpack. So there are various versions of Jetpack compatible for different kinds of boards. So maybe one board can have 3 or 4 versions of Jetpack. So Jetpack is a overall bundle which flashes the operating system, which is the Jetson, in our case, the Jetson OS, along with the CUDA drivers which are required for that particular version of the board. So for Jetson Xavier, there will be one version of CUDA drivers compared to Jetson Orin because the SoCs are completely different. So I have given the link of a sample video on how to set up a Jetson board and the online documentation. Please do have a look. And this is a very brief overview with respect to the uh, Nvidia Jetson boards and the background with respect to what Orin means, what ampere, what volta, what hopper means, and how they are basically uh, creating the SOCs and how these SOCs are deployed into different hardwares based on the industrial requirement and the safety requirements as per the industry standards. Thank you. Thank you for your time.